Hello students, now we are looking at independent events. Independent events. If events A, B, C are independent, the probability of A and B and C happening is the product of their individual probabilities. Now, look at this. When we talk of independent events that will happen simultaneously. Now, let's say myself and some other two people are meant to go to a place. So if I have my own probability of going to the place, the other two people, each of them have their own probabilities. So the probability that all of us, the three of us, will go together will be, you multiply the probability of myself going, each of the other two going, multiply our probabilities together. That is what independent events that happen simultaneously. So how will you do that? You do that by what? Multiplying the probabilities together. Now let's look at this example. Two dice are thrown once. What is the probability of getting A, 2, 6, B, 2 prime numbers, C, 1 odd and 1 even numbers? Now, we have done, if you watch the previous videos, we have done this. We can do this by defining this, writing out the two dice and start counting. This solution is the alternative way of doing it. Now look at this. We have two dice are thrown once. Then you having two dice, you throw it once. What is the probability of getting 2 6? That means on the first die you want to have a 6, and on the second die you want to have a 6. Now in a die, the outcomes you can get is 1, 2, 3, 4, 5, 6. So you can get 6 outcomes. So the probability of getting 1 6 here, so this is 1. We only have 1 6 here, so that's 1 over then the total number of outcomes 6. So the probability of getting a 6 when you have cast a die is 1 over 6. Now if you now have 2 dice, you cast it. Now what is the probability of getting 2 6? That means you want to get the first one to be 6 and the second one to be 6. So you can see that this type of event will happen simultaneously. The probability of getting the first one to be 6 and the second one to be 6. So now you get the probability of getting the first one to be 6 is to be 1 over 6. The probability of getting the second one to be 1 over 6. So now to get both of them to be 6 6, that means you are going to multiply their probabilities. So that means say 1 over 6 times 1 over 6. So which will give you 1 over 6 times 6 will give you 36. The second part says, what is the probability of getting 2 prime numbers? The first one to be a prime number and the second one to be a prime number. So first of all, how many, in a die you having 6 faces? So the prime numbers, what is a prime number first? A prime number is a number that can only be divided by 1 and itself. So the prime numbers here are what? We having 2, we have 3, and we have 5. How many prime numbers we have here? 1, 2, 3. So in one cast of a die, the probability of getting a prime number will be 3 over the total number of outcomes, which is 6. So 3 over 6 to the lowest term will give us 1 over 2. Now we want to have 2 prime numbers, that the probability that the first one is a prime number and the second one is a prime number. So the probability that the first one is a prime number is 1 over 2. The probability that the second one is a prime number is also 1 over 2. because this want the two to happen simultaneously. That means we want to get a prime number and a prime number. Because of that, we are going to multiply their probabilities. So 1/2 times 1/2. 1 times 1 will give us 1. 2 times 2 will give us 4. Then the C part of the question says that what is the probability of getting one odd and one even number? One odd and one even number. Now, first of all, the probability of getting an odd number. Now, if you look at this, so the odd number here are what? We having 1, 3, and 5. So how many odd number? 1, 2, 3. So that means you're having 3 odd numbers over the total number of outcome, which is 6. To the lowest times give us 1/2. The probability of getting an even number. How many even number do you have here? 1, 2, 3. So you're having 3/6, which is also 1/2. Now, the probability of getting one odd and one even. You will notice something in this tone, on the tone of this question. The question is not telling us the arrangement of how we want to get the odd and the numbers. We are not told if the odd number will come first and the even number coming next. So because of that, we are going to look at the two possible arrangement. So it's either the odd number coming first and the even number coming next, or the probability of the even number coming first and the odd number coming next. So that means one odd, this is still one odd, one even. One odd, one even. But you are going to, since the question didn't specify the arrangement of how it's going to be, because of that, we are going to try the two possible situations. So it is either we have one odd number and even number, or we have one even number, the first one to be even number and the other one to be odd number. So now you realize that this and this, odd and even, this one will happen simultaneously. Because of that, we will multiply the probability. And even and odd, so this also will happen simultaneously. We multiply the probability, because only one of these two are what we are list. Either we have probability of odd and even, or probability of even and odd. Because the probability of or this even, so because of that, we are going to add their probabilities. So first of all, the probability of getting an odd number is 1/2. Of even number is 1/2. So probability of having odd and even will now be what? You multiply the two probability. Then because of this, or you add to the probability of having an even number is 1/2. Probability of having odd number is 1/2. So you multiply them, because this also happens simultaneously. It's either we have this one or this one. So that is why we are now adding, after multiplying each of these, we will now add the answers together. So 1/2 times 1/2 will give us 1/4, plus this also will give us 1/4. The LCM of 4 and 4 is 4. How many 4 and 4? 1. 1 times 1 is 1, plus how many 4 and 4? 1. 1 times 1 is 1. 1 plus 1 will give us 2/4. 2/4 to the lowest value will give us what? 1/2. Now let's consider this question. A basket contains 3 red balls, 5 blue balls, and 7 green balls. 2 balls are picked one after the other with replacements. Find the probability that both are red. First is blue, the other is green. One is blue, the other is green. Both are of different colors. They are of the same color. Now, let's look at the question again. a basket contains 3 red balls. So assuming this is the basket, it contains 3 red balls, 5 blue balls, and 7 green balls. So 2 balls are picked one after the other with replacement. So now this with replacement, it means that after picking the first ball, I'll return it before I pick the second ball. That's what it means. After picking the first ball, I will return it before I pick the second ball. So now, what is the probability that I will now pick both balls to be red? So first of all, you need to make it easier, let's look for the probability of picking red balls. The probability of picking red ball will be what? How many red balls do we have there? That is 3 over the total number of balls we have in was 15. So 3 over 15. You can do this to the lowest term, which is 1 over 3. Then the probability of picking a blue ball. How many blue balls do we have there? We are having what? 5 over 15. To the lowest term, we are having 1 over 3. Sorry, this one will give us 1 over 5. 3 over 15 is 1 over 5. Then the probability of having a green ball. How many green balls are there? We have 7 over the total number of balls here. We are having 15. We have 15. We want to look at the probability of having both of them to be red. So the probability of the first one being red and second one being red. So probability of the first one being red and the second one being red. So the probability of the first one being red is what? 3 over 10. 3 over 15 rather. The probability of the second one being red is also 3 over 15. So 3 over 15 to the lowest term will give us what? 1 over 5. Probability of the second one is also 1 over 5. Because both of them will happen simultaneously, we are picking 2 balls. So that 2 balls, so the first one is red and the second one to be red. So that means we are going to multiply their probability. An indicator to show independent event is what? And so this and this will happen. So 1 over 5 times 1 over 5, which should give us 1 over 25. Then the second one question says the probability that the first is blue and the other is green. So the probability that the first is blue and the other one is green. So since it is and, so look for the probability of the first one to be blue, which is 5 over 15. And the probability of the second one to be green is 7 over 15. So when you do this to the lowest term, 5 over 15 is same thing as 1 over 3 times 7 over 15. So 1 times 7 will give us 7 over 3 times 15 will give us 45. So the probability of having the first one to be blue and the second one to be green is 7 over 45. Then the third one says, what is the probability of having the one to be blue is blue, the other is green? Now we are not told if the blue should come first or the green should come first. So in this situation, we are going to try the 2 possible ways in which this can happen. It's either we have the blue first before we have the green, or the probability we have the green first before we have the blue ball. So that means it's either the probability of blue and green, or the probability of green and blue. So the probability of blue and green is what? Blue is 5 over 15. The probability of green is 7 over 15. So because blue and green, so you multiply them because both of them are happening simultaneously. Because you're having or, That means you add the probability plus then the probability of the green coming first is 7/15 times the blue coming next is what? 5/15. So you multiply it. So this one will give us 5/15 is same thing as 1/3 times 7/15 plus 7/15 times 5/15 is 1/3. So 1 times 7 will give us 7/3 times 15 is 45 plus 7 times 1 is 7/15 times 3 is 45. So from here you look for the LCM. The LCM of 45 will give us 45. How many 45 are in 45? We have 1. 1 times 7 will give us 7 plus how many 45 are in 45? We have 1. 1 times 7 is 7. 7 plus 7 will give us 14/45. 14/45. Now, the D part says that what is probability of getting different colors? The probability of getting different colors. In this situation, you are going to look for the different ways of combining the colors to make them different. So now, assuming, look at this, you are going. It's better to first of all have the arrangement this way. Now you have red, blue, and green balls, and you having red, blue, and green balls. If you want to be combining them, you see that you having red, 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 blue, red, green, blue, red, blue, 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 green, or green, red, green, blue, green, green. Now, if you look at this here, the probability of getting different colors will be, if here you have, see that you have red and blue, or red and green, or blue and red, or blue and green, or green and red, or green and blue. So you can see that these are the possible ways you can have the balls, pick two balls in different ways. So you see that you having red and blue, red and green, blue and red, blue and green, green and red, and green and blue. So the probability that both of the colors are, you have different colors, will be probability of red and blue, or probability of red and green, or the probability of blue and red, or the probability of blue and green, or the probability of green and red, or the probability of green and blue. So to make it easier, let's look for their individual probabilities. The probability of having red and blue. The probability of red is 3/5. The probability of blue is 5/15. So because red and blue, you multiply them, so you are going to get 1/15. Then to get probability of getting red and green, so the probability of the first one to be red is 3/15. The probability of the second one to be green is 7/15. So multiply their probability, so you get 7/75. Then the probability of getting the first one to be blue and the second one to be red, so that 5/15 is the first one to be blue and 3/15 is the second one to be red. So multiply them, so it should give us 1/15. Then the probability of getting the first one to be blue is, and the second one to be green. The probability of getting the first one to be blue is 5/15. The probability of getting the second one to be green is 7/15. So when you multiply them, you are going to get 7/45. So the probability of getting the first one to be green is green and red. So the probability of getting the first one to be green is 7/15. Second one to be red is 3/15. When you multiply them, you get 7/75. Then the probability of getting the first one to be green is 7/15 and second one to be blue is 5/15. From here you multiply their probability, you get 7/45. So you realize that the probability of having different colors is either you have red and blue, or red and green, or blue and red, or probability of blue and green, or probability of green and red, or probability of green and blue. So because only one of these cannot happen, you now add all their individual probabilities. So 1/15 plus 7/75 plus 1/15 plus 7/45 plus 7/75 plus 7/45. So the LCM of everything here will give us 225. How many 15 and 225? 15. 15 times 1 is 15 plus 17 is 225 is 3. 3 times 7 is 21 plus 15 into 25 is 15. 15 times 1 is 15 plus 45 into 25 is what? That is 7. That is 5. 5 times 7 is 35 plus 75 into 25 is 3. 3 times 7 is 21 plus 45 into 25 is what? 5. 5 times 7 is 35. So you add all this numerator together, you are going to get 142 over 225. If you do this to the lowest term, you will get 52 over 75. So it means that the probability of getting different colors will be 52 over 75. Now let's answer the third part, the last part of the question, which says probability of picking the two balls to be of the same color. You realize that to pick them to be of the same color, it can happen in 3 ways. You see that you have probability of picking red, or the probability of picking blue, or the probability of picking green. So now let's look for their probabilities. So probability of picking red, that is 3 over 15 times the probability second one to be red, 3 over 15. So multiply them, you get 1 over 25. Then the probability of picking blue, the first one to be blue is 5 over 15. Second one to be blue is 5 over 15. When you multiply this, you get 1 over 9. Then the probability of picking green, the first one is green is 7 over 15. Second one is green is 7 over 15. So when you multiply their probability, you get 49 over 25. So the probability of having them to be of the same colors. So you see that the probability of red, which is 1 over 25, or because you're having or, that means you add. Then the probability of getting blue, which is 1 over 9, or that is plus the probability of getting green, which is 49 over 225. So if you look for the LCM of 25, 9 and 225, you are going to get 225. How many 25 and 225? That's 9. 9 times 1 give us 9 plus 9 into 225 is 25. 25 times 1 will give us 25. Then plus 225 into 25 is 1. 1 times 49 is 49. 9 plus 25 plus 49 will give us 83 over 225. So that means the value is 83 over 225. Now alternatively, you can also do it this way. Now look at this. When we were looking at the different ways you can have the combination. So it's either we have different colors or the same color. So it's either we are having probability of different colors or the same color. So if we don't have different colors, it means we are having the same color. So you can do this instead of doing this last one and looking for the probability of red, blue, green. You can say that since we have been able to look for the probability of different colors, we were able to look for the probability of different colors to be 52 over 75. So what you just do is to subtract the probability of different colors from 1 So what you just do is subtract the probability of different colors from 1. You realize that 52 over 75 same thing, 142 over 225. So the probability of different colors is what? 142 over 225. Subtract it from 1, which will now give us the probability of having the same colors. So 1 minus 142 over 225. So this one is same thing as 1 over 1. So how many? The LCM of 1 and 225 will give us 225. So then 225, 1 into 25 is 225. 225 times 1 is 225 minus 225 into 225. That's 1. 1 times 142 will give us 142. 225 minus 142 will give us 83 over 225. You can see that we got the same answer in the two situations. So since it's either you have the same color or a different color, and you've been able to look for the probability of the same colors, what will you now do? You can just subtract the probability of different color from one whole number to get the probability of the same colors. So for the work practice, you are going to do this. A crate of soft drink contains 9 bottles of Coke, 6 bottles of Pepsi, and 4 bottles of Limca. Ademola picks 1 bottle of soft drink and then replaced. Thereafter, Adedeji picks another bottle. Find the probability that A. They both picked Limca. B. Ademola only picked Limca. C. They both picked the same brand. D. They picked different brands. Then number 2. A box contains 5 blue marbles, 3 black marbles, and 2 red marbles. Of the same size and shape. A marble is selected at random from the box and then replaced. A second marble is then selected. Find the probability of obtaining 2 red marbles, 2 blue marbles, or 2 black marbles. Then the third part says that 1 black marble or 1 red marble. Please ensure you like, subscribe, and comment on this video. Thank you.